Hello. I
Hey,
hope you can
Martin.
hear me. Hi, how are you?
Good. How are you?
Can't complain.
Nice. Thanks for being here.
Let me see if I can start my video too. Yeah, cool.
Nice.
A fashionable backdrop. I hope that InstaDeep is not mirrored, is it? You can actually read it.
Paul, can you please let Jadidi in?
Sorry. Just 1 second.
There's so much lag between the Zoom call and YouTube. It was about like 30 seconds. I got such a fright when I heard my voice.
Why am I talking? Okay. So I don't see Karim yet, but otherwise I think everyone's here.
Hello.
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 So it's Merchant from.
Yes, that's me.
Yeah, hello. Nice background.
Yeah, I like it too.
Welcome, Habib. Can you hear me?
Yeah, hello, good morning.
Yes.
How are
Hi,
you?
morning. I'm
Thank
good.
you
How are
for
you?
your invitation.
Great. Thank you
Hi,
very much for being
colleagues.
here.
My pleasure.
Can I please ask you what your title is, how I should introduce you?
Title, I'm professor at the university, so. And
Okay.
regarding the organization, IEEE Tunisia section, I'm the past chair.
Okay. Okay, great.
My pleasure.
Thank you. Okay, so I'm just going to switch everybody's video off for now, and then when we're ready, we can go ahead, and I'll just re-add you. Welcome everybody. Just waiting for a few people still to join. Hi Karim, welcome. I'm just gonna.
Hi, good morning.
We're just starting now. Thanks for joining us. Okay, so I think people will still slowly be joining, but I'm happy to get started as well. I don't want to waste too much time. So a very, very warm welcome to everybody. Thank you so much for joining us here at UmojaHack Tunisia. We're thrilled to see the turnout that we've had. We have, I believe, 15 universities, more than 200 students signing up. That's really a phenomenal turnout. And so we're really, really excited about this. And I think we're also very excited about the challenge that we've got for you today. I'd also like to say a very big thank you to our sponsors and partners. I'd like to say thank you to InstaDeep, represented here today by Martin Squark, Mohamed Jadidi, and of course, Karim Bigir, who will go from soon. I'd also like to welcome Habib Kamoun, Prof. Habib Kamoun, who is representing IEEE Tunisia section, who have very gratefully or have very graciously sponsored us for this event. And I'd also like to extend a welcome to our ambassadors, Mohamed Jadidi, Eza Kasuri, and Haytham Tulili. So a big thank you to everybody, particularly to our ambassadors for working hard behind the scenes to make this event work. Thank you to our sponsors, to our partners, and thank you to all of you representing the universities and all of the students who've given us your Saturday. We really appreciate all of you being here today. And I hope that you will find this an enjoyable experience, and I hope that you will learn something as well. So just briefly, for those of you that don't know Zindi, we are a data science competition platform that focuses on Africa. We are approaching 20,000 users. Those users are something like 3/4 of them are in Africa, but we also have users in almost 200 countries around the world. We take pride in representing Africa and putting African data science on the map, and we hope that Zindi will forever be a place of community and welcome and learning for African data scientists, a place where companies can come to get really fantastic real world data science solutions, but also a place where you as learners and people on your data science journey can come and join and grow and learn and network. So I don't want to go into too much detail about the competition just yet. I'd like to first off welcome Karim Bigir and ask him to address us briefly. Karim's from InstaDeep. Karim, over to you. I just want to make sure you can speak.
If you can just enable the video, thank you.
Okay, sure. Okay. You should be able to use your video now.
Yeah, it sounds like it works. Thanks a lot, Paul, for the introduction, and it's really a pleasure to have this event organized by Zindi. And you know, for InstaDeep, this is really exciting because we participated in many events partnered with Zindi, but now we are back home in Tunisia. So for me, it's a special pleasure to be sponsoring and organizing this event with Zindi and our other partners such as IEEE. So I wanted to just give you a sense of why I think this is important for the future. So I just put a few slides to explain why what we are doing is quite important for the future of our communities and countries. And so we really are living in a time of disruption, and a good way to understand technology disruption in the 21st century is to see AI at the heart of this disruption. And it's like AI is such of like the center of the solar system of disruption, and it's impacting all industries: mobility, robotics, energy, anything you can think of, biotech, like for today's challenge. And this is possible because you have a triple exponential of progress in AI. We know very well that AI, data in AI is growing exponentially. All of you are also familiar with Moore's law, that compute power grows exponentially. But perhaps less obvious is the fact that the algorithms themselves are also evolving exponentially. And in this graph that you see here, you can get a sense that basically efficiency of AI algorithm doubles every 16 months. That is insane. That means that you need in 2020 45 or 44 times less compute power than you needed in 2012, 2013 for a given, for example, AI vision task. Importantly, this means that if you combine these three trends, data, compute power, and exponential progress in the algorithms, we are truly living in an age of disruption where things that were impossible before become possible. And I think this is an opportunity for Africa and for all our countries to step up and become like sources of innovation. So, if you look in the world, who owns the data and who drives AI innovation, it's very clear that in the US, it's the tech giants, Google, Facebook, Microsoft, Amazon, all these are leading firms that use machine learning in all their operations. In Europe, you have innovation in terms of like encryption technologies and making sure you have privacy while getting the benefits of machine learning. In Asia, you have a very strong governments such as China, which are driving the revolution. But the question is, for us in Africa, what is the opportunity and how could we drive innovation? And I strongly believe that it's actually with startups and communities, pretty much exactly what we are doing today at the UmojaHack, linking innovative startups such as Zindi, such as InstaDeep, and the community at large, with all the universities represented today. We have more than 15 universities in Tunisia and engineering schools participating in the competition. So it's this notion of us as a community plus our startups, like, can we do new things? And the answer is, I believe, a big yes. We can do new things. And for today's competition, we actually focused on bringing in a truly novel type of problem, which is in biology. So we're going to look basically at how to recognize different enzymes which are important for the functioning of our cells, of our systems, basically, and use machine learning to do that. What I want to emphasize is this is actually a deep tech type of problem. But today it is possible for young talented participants such as yourself, for startups such as Zindi and InstaDeep to actually lay the groundwork for the problem and hopefully together solve it. And it's really an exciting time. As the co-founder and CEO of InstaDeep, I'm also proud that we are the gold sponsor of this event and we're participating significantly to the prizes. There is a total of 11,000 dinars to be distributed. But really, this is for me an excuse. What is key is that all the talents that we have participating in this competition, tackling problems that are truly important, truly impactful for the future. If anything, we saw this year how important, fighting against diseases is. But I believe that there is a future where our countries, our startups, our communities work together to create disruptive innovation. So this is the strong message and strong positive message I wanted to convey. And obviously, we strongly encourage you to get interested in machine learning. I'm sure you'll find the competition quite interesting today, but this is really an opportunity to hone your skill, see if you like the field. And if you like the field, there will be a ton of amazing opportunities for you in the future to work at startups or be part of research projects in universities. So this is truly an exciting time. And we're very honored to have for this competition also the support of the Tunisian government, in particular the DG of Innovation, Mr. Qais Mejri of GIZ, of IEEE, as we mentioned. And I think this is a sign of things to come. So that's the message I wanted to convey. Thanks again for participating to this first competition between different universities and different engineering schools. I think this is super exciting, and I wish you good luck for the competition. And thanks again for participating.
Thank you so much, Karim. Let me just do this. Thank you so much. Yeah, really fantastic to hear from you, Karim, and I think really very exciting for us at Zindi to be hosting a problem like this. We have very few. This might be the first true molecular biology problem on the platform. For me, with a personal background in molecular biology, it's really exciting to see. I hope you all as participants aren't too intimidated by the jargon and the scientific aspect of it. I think it's really a phenomenal and really an innovative challenge. So I'm really excited about that. Next up, I'd like to invite Prof. Habib Kamoun to address us. Prof. Kamoun is the former chair of IEEE Tunisia section. We're really very grateful to IEEE for coming on board as a partner and sponsor for this event. Prof, the floor is yours. Sorry, Prof, I think you're muted. I don't know what happened.
No, it's okay.
Okay.
Thank you, Paul, for your introduction. So it's really great pleasure to be with you today. Thank you, Zindi and Ansadi, for your cooperation. It's really a great pleasure to be with you today in this opening session for the hackathon. Thanks to all participants who registered to this important challenge, that and I hope that they will learn a lot of things and they will be able to improve their skills. This is very important today's to learn more about artificial intelligence, and we are convinced that this type of challenges is a great opportunity to all students in our universities to improve their skills, because this is the right way to be with good level of expertise and be able later to develop great solutions. So just as brief presentation of IEEE, IEEE is the largest international technical and professional organization with more than 400,000 of members, engineers in different technical fields, including computer and computational intelligence and the part of artificial intelligence. So we are in Africa, we are about 7,000 members, and in Tunisia it's represent 40% from Africa. Like we have more than 3,000. We are glad to have a good number of IEEE members in this hackathon today. In addition to that, so IEEE is managing some communities that are tackling with big data, with blockchain, with smart cities, and several other communities. So I encourage all students to join for free these communities, and I'm sure that they will find a good opportunity to improve their skills more and more in order to succeed their professional careers. So this is just a brief introduction from my side, and I wish all the best for the participants, and I'm looking to the projects, successful projects at the end of the day. Thank you, Paul. And thank you, Zindi and Sadib, for your cooperation. It's really great pleasure.
Thank you so much, Prof. That's very much appreciated. Your kind words are very much appreciated. And we hope that this is the start of a much longer working relationship with IEEE. Okay, so from here, I'm going to get into more of the details of the competition. I'll just talk you through the schedule for the day, as well as some of the more important rules, some of the prizes, and then I'll hand over in the second half of this briefing, I'll hand over to Mohammed Jadidi to take you through a more technical tutorial and a starter notebook, which we provide to make getting started on this competition a little easier. So I'm going to just share my screen. Okay, so I'm showing you the homepage for this hackathon. There you can see the URL at the top. It should be shared with you. If you haven't signed up, you can do so here. Just enter your details, but I don't need to sign up, so I'll just sign in. So once you're signed in, you will need to join the competition. I've joined the competition already, so there should be a little orange button there that says join, and you'll be prompted to enter a secret code, which you can get on the discussion forum or from your reps. Once you've joined, you can see there's a basic information page. This will tell you all about the competition, some of the more technical information, and a little bit about our sponsors as well. Then I'm gonna just jump around a little bit. You can look at the timeline here. This is where we're at the moment, the welcome and orientation. There's then a technical orientation from Mr. Jadidi. The competition itself will open at 10 a.m. local time. That's when we will share an access code, because the data is currently encrypted. So we'll share an access code so that you can get the data. For the first hour, Mohammed Jadidi will stay on this Zoom call to answer any questions you may have. So if you are unsure where to start, or have a question about the notebook or any other technical question, he'll be available. Then over lunchtime, our one of our resident data scientists, Jono Whitaker, will be doing a live stream. We'll share the details of that when we have them. But basically, that will be a time where if you are feeling really stumped or you need some new ideas, Jono will show you some of his thinking and some of his approaches, and you can also have a chance to ask questions there. The competition itself will close at 7 p.m. 7 p.m. local time, so you have 9 hours to work on the challenge. Your last submission should be in at or before, it should be in at 6:59 p.m. Submissions will close at 7, and then we have 15 minutes of processing time on Zindi side before we meet back at this on this Zoom call again to announce our winners. So talking of winners, here you can see your prizes. We have prizes both for universities as well as for university students, and we also have some tablets very graciously given to us by the Tunisian government. Who
actually, Paul, I wanted to mention Mr. Qais Mejri, the Director General of Innovation at the Tunisian government, and who is providing those prizes, is online. So maybe he wants to say a few words on that as well.
Fantastic. I didn't realize. Thank you very much, Karim. I'll hand over shortly to you, Mr. Mejri. So yes, so as I was saying, there are these prizes. Something just important to note about the prizes is that we only give out one prize per university. So that's to say, if there are two, say first and second prize both come from the same university, we'll only give a prize to the winning team from that university, and the next prize will go to the next winning team from a different university. And that's just to make sure that the prizes are distributed as much as possible, as best as possible. Okay, before I go into the rules, just I think it's important that we have the rules briefly, but I would then like to hand over to Mr. Medri. Let me just make sure I can add. Mr. Medri, you should be able to share your screen. Could you try to do that and see if it's working? Are you there?
Well, I think there might be an issue with the video, so
Yes,
maybe we can come back to it later.
see.
Yeah.
Let me try once again, and then we can come back. Mr. Medri, are you able to join us? Okay, right. Please let me know when, if you can hear me, please let me know when we should go ahead and we can add you. Okay, so I'll go back to sharing my screen. Okay, so then just to quickly touch on some important rules. In terms of making a team, you're welcome to participate in a team of up to 4 people, or you can participate as an individual. You can form a team by going to this tab here, team, create a team. There's some rules there. You can name your team, and then you can invite people to a team by typing in their username here. I'm going to invite Zindi, and then that person will receive an email. So that's how you start a team. And just going back to the rules. Okay, so as I say, you're welcome to start a team. If you form a team, if you are in a team, you will be able to, or you'll win prizes as a team rather than as individual. Prizes will be shared. I see Mr. Medri has joined us, but you're still on mute. Would you be able to unmute yourself? Are you ready?
Bonjour.
Bonjour.
Hello, everybody. So
Hi there.
I'm happy to be with you this morning, and I want to congratulate all the participants for this amazing challenge. I am so happy that it happens in Tunisia, and I am happy also to welcome back Karim for this event after organizing the AI Hack Tunisia last year. And I congratulate Zindi for this really amazing synergy and the energy that they are making in Africa in AI and data science in general. I hope all the participants good luck, and I hope that someone make a great discovery, a great solutions for this challenge. I want to say that Tunisia and the Ministry of Industry and Energy is really focusing and making a lot of interest on AI. We are working on a strategy to develop and promote AI in Tunisia, and we are so happy that that it is already happened in the NGOs and in our startups and bigger startups like Instadeep. So I'm happy to be with you, and I want to say good morning, good luck for everybody for this event.
Great, thank you so much, Mr. Mejri, and we really appreciate your enthusiasm and the support from the Department of Industry and Energy. It's really wonderful to have that support, and we hope we can make you proud. Okay, so going back to going back to the rules. Seems a little bit boring after hearing from other people. Okay, so I discussed the teams. In terms of collaboration, we really do encourage collaboration on Zindi, but that collaboration should be within teams. If you're going to be sharing code, that should only be with your team members rather than sharing code with other people, because that would constitute a breach of the rules. You're of course welcome to talk to each other about your approach and how you're going about it. The sharing of code is what needs to be avoided. So the data sets available to you are all on Zindi already. There are no other data sets required. Your solution should also only use publicly available and open source languages and packages. We don't allow automated machine learning tools, but we do allow pre-trained models as long as they are openly available. Something like ImageNet, that would be open. The data belongs to Zindi and to Instadeep, so you are not permitted to transmit it, duplicate it, publish it, or share it beyond downloading it for the purposes of participating in the competition. And the winning solution will belong to Instadeep. We allow a maximum of 100 submissions per day, and you'll be judged on your highest scoring solution. If you don't know exactly how Zindi's competitions work, we have both a public leaderboard and a private leaderboard. So when you make a submission, your submission will appear here on the public leaderboard. That is your submission evaluated against one part of the test set. We also maintain a private leaderboard, which evaluates your submission against another part of the test set to stop overfitting. And the final positions and final scores will be judged on the private test set rather than the public test set. So that means that at the end of the competition, sometimes people move around at the top of the leaderboard. So just to be warned. Where else? What else is there? So that's submissions and winning. Trying to think if there's anything else. Oh yes, the only other thing to mention is that to participate in this challenge, you must please be a registered student, a registered undergraduate or graduate student at a Tunisian university. Lecturers, researchers, and other university staff are encouraged to participate in an advisory or mentorship role, but please don't participate as a competitor. So I think that covers everything I wanted to say. I'd like to hand over to Mohammed, who will take us through the notebook that we've prepared, the starter notebook, talk to you a little bit about some of the approaches you might take, and then also show you how to make a submission on the leaderboard, after which time we will share the access code to the data and we'll be able to start the competition. So, Mohammed, over to you.
Yeah, so I'm here. So hello everyone. So I hope you are doing well during these circumstances. So it's my pleasure to be with you today in the first edition of UmojaHack Tunisia. So first of all, I would like to thank all the Zindi team and all the Zindi ambassadors for their work that they have done. So actually, let's start with an overview of this challenge from the biological perspective. So please help me welcome our best data science and biologist immersion.
Okay. Hello. So I'm Marcin Skwek, and well, I'm a data scientist at InstaDeep, but really, I'm a computational biologist. The task today is, hopefully you can hear me. The task today is the classification of protein kinases. Protein kinases are a very abundant class of proteins, of enzymes in living organisms. And what they do is they transfer a phosphate group, but they activate other proteins. And they make them work better or slightly less good. They make them change their specificity, so they make them act on something slightly different than they used to act on. And they are effectively the mechanism that makes the life work and makes life react to the circumstances. The importance of start my video, sure. The importance of protein kinases can be exemplified by the fact that approximately 15 years ago, maybe 20 years ago, a new class of drugs has been developed, protein kinase inhibitors, which have changed a lot of cancers from effectively death sentences to chronic manageable conditions. And today, we're going to focus on just a small, actually not that small, subset of the proteins that come from all different walks of life. And we would like to classify them into 10 general functional categories. The interesting thing about protein kinases, or enzymes in general, is that they are very, very similar to each other. But a lot of the functionality has developed independently. They all stem from the same ancestor, but they went different ways, which means that there are protein sequences that are similar to each other, but they do different things. And then there are protein sequences that are dissimilar, but they do the same thing. And we don't want to classify them based on the similarity in terms of sequence space, in terms of edit distance, but rather in terms of their function. And that's possible because we know that these kinases, these proteins, all work, if they do the same thing, they work in the same way. So they have a particular sequence motifs somewhere in their sequence that make them special, that set them apart from the others. And we know that this task is not only possible, but also interesting. There's an active research field in classifying different enzymes, kinases being one of those. And it's not really just an academic endeavor, because even though we have so much annotated protein sequences, there's way more of the proteins that we don't know anything about. Proteins that we've sequenced from soil samples and ocean water samples, and from any other environmental samples, in fact. And if we could annotate these, if we could get some sort of shed a bit of a light on these, that would be really, really important, really useful, and it would make an actual novel-centric contribution. And I believe that with so much talent participating in this hackathon, I believe we can make that happen. And thank you.
And importantly, I wanted to mention also, thanks, Martin. Really, like from a machine learning point of view, the problem is actually very clear to describe. You literally have sequences of amino acids plus features, and your goal is to make basically perform a classification task. So it is pretty straightforward from a machine learning in terms of explaining the problem. However, as Martin mentioned, this is an interesting problem in bioinformatics, and potentially the solution that we collectively are going to have might be very interesting. So thanks a lot, Martin, for this.
Pleasure.
Thanks again, Roshan, for your gentle overview and introduction. So now let's have an overview from machine learning perspective only. And I am sorry, Roshan, about what I'm going to say. So actually here we have a sequence of amino acid as an entry, and we aim to predict. And actually we aim to predict n classes. So this amino acid are letters A, B, C, D, and so on. So we can see this task as an NLP task, a sequence of word, and we aim to predict a variety of classes. So certainly here we need to apply an NLP techniques or methods. So like word embedding, using LSTM layers, transformers, BERT model, why not? So let's start with the deep learning approach. So actually I am going through the deep learn through the starter notebook that it will be shared with you. So actually are you seeing my screen?
Yes.
Yeah.
Okay, perfect, fantastic. Okay, so actually here we are going to use TensorFlow library. So for sure you feel free to use any other library like PyTorch, FastAI, and so on. Okay, here, I'm going through the code. So the first thing, in the OS environment, code a visible device. So this command allows you to choose which GPU that you can use. So in your case, so if you have only one GPU, so you can set it to 0. Otherwise, so you will face an error because you don't have the GPU ID equal to 3. Okay. So the first step, we need to process our data. So we are going to load the train and the tests, which are CSV format. So this data this will load in data frame. Contains the ID, the sequence, and the target. Okay, so here we are going to process the sequence. So since we are going to use a data loader implemented by TensorFlow, so we need to convert the sequence from data frame to a text file. But before this, so we need to split our train data to validation and train, to use a cross validation strategy. So here in this notebook, so I am using a simple one, is just to split the train into a partition with 10% size for the validation. So now let's come to the sequence length. So actually, in our data set, the max sequence length is about 550 amino acid. So actually, the max sequence variable depends on your computing power. So if you have a good GPU, so you can keep it as it is. Otherwise, so you need to decrease it, because if the training process is taking a while, so for sure you need to decrease it, or maybe you can face a CUDA memory issue. Or but for sure, more higher sequence you use, more higher sequence length you use, you get a better score. So it's trade-off. Okay. So from my side, I am going to keep the max sequence length to 550. So I don't need to do this. So actually I don't need to reduce the sequence length. So the second step is to write the sequence into text file. So already I defined a function to do this is write to text. So this function will take the file name that that the sequence will be saved on, and the sequence. So I will do the same thing for the for the test and for the validation, to save them in a text format, and I am going to save the target for the train and for the validation. In so we can create a folder called prop data or whatever. We can save it in the same folder of the notebook. So actually, from after you do this, so you don't need to do this again in the next run. So in the next run, or in your next experiment, so you can skip this step, because already all the file was saved, so you don't need to do it anymore. So here we are going to define our data loader. So why? So actually, the question here, why I use the data loader, because it's not feasible to create data with the shape 300 k rows multiplied by 500 features. So that's why we are using a data loader. So the data loader will allow us to create during the train this array in small size. So that means if you define the batch size to 500, for example, so in each batch, so the data loader will create array with shape, the batch size, the sequence length, which are 500 and the 50, and input, and the feature is one, so the amino acid sequence. So actually we use the data loader to avoid any memory issue during the train. To define data loader, so we are going to load our targets for the train and for the validation. We are going to find the train batch size, the validation batch size. So for sure you can decrease them. So if your GPU memory doesn't support this number of batch size, so we can use 500. Okay, so we are going to define the number of classes. So the number of classes is the train from the train label, the target n unique. The train steps, so this is needed to the data loader that allow the model during the feed function of the model to know how many steps in each epoch. So we are going to define the vocabulary. So our vocabulary, so we have almost 24 amino acids. So with RPV and so on. We are going to create the dictionary map, so which allow us to map the amino acid to an integer. Because like the model understand only numerical value, so we need to change the string format to an int format. So actually here we are going to define the data loader finally. So the data loader is composed of two data loaders. The first one is to load the targets. The second one is to read from the file that we created, and we can zip them, so they will be generated with the associated entry so for each entry we will associate the right label. We will do the repeat functions, allow the data loader to actually since the data loader is a generator, so we need in each epoch to recreate recreate the generator. So we'll process the shuffle. And after it, so we need to apply the encoder function. So this function will convert the amino acid from letters to an int value. And we will do the batch. So we'll create the batch, the batches, and we do the prefetch. So we do the same for the test, but without the label. So here we are going to define finally the train data loader and the validation data loader. So actually our pipeline is ready now to be fitted to our model. So the last step is to define our model. So actually, since we are dealing with NLP tasks, so we have a sequence as an input. So the first thing that we need to do is the embedding layer. So the embedding layer will allow us to convert the input, the integer input to high dimension space. So in our case, so I chose our high dimension space to 64. So after doing the embedding layer, we will pass this new dimension feature, this new map feature through LSTM, but actually through bidirectional LSTM. So the bidirectional LSTM is actually is doing the LSTM in both direction, from right and from left, and actually it will concatenate all the features of the first pass and the second pass. And after doing bidirectional LSTM layer, so we will pass them through to the dance layer and finally to the output layer. And we will apply the dropout layer after the first dance layer. So actually we'll define all this calculation, and we'll get finally the logits. So we'll define our Keras model. The input will be the sequence, which we define it here, and the output is the probability of each class. We'll define the optimizer, so we'll use the Adam optimizer, a common one. We'll compile our model and we'll give them the optimizer, the loss that we are going to use, which is the category cross entropy, and the metric So we'll use the categorical accuracy metric, and finally, so we'll return our model. So this function, so the function model will allow us to create our model. Okay, just one sec. Okay. So here, this is our final architecture. So you can see the total parameters that we are going to use. So now the final step is to run the model. So it will take a while for sure. So actually here you can see the loss function and the accuracy during the train. And so actually here, so what you need to add more, if you would like to improve the score, is to use the callback method, like the early stopping method, and actually save the model in the best iteration. So after the training run, so you will create the test data loader and do the prediction, and actually save this prediction in CSV file. So we're going to create a data frame contains the ID and fill the columns with the model prediction, and you save the submission file. Okay. So this is for the deep learning notebook. So actually, we thought about the people who are not familiar with the deep learning. So are they not familiar with deep learning? So we add some data that allow them to attack this problem from traditional machine learning perspective. So actually, in the data that will be shared with you, so we will find another CSV file called amino acid embeddings. So actually, this file contains the embedding of each amino acid in 1024 dimension space. So this feature is the embedding extracted from a deep learning model. So actually, how we can use this feature? How we can use this feature is to apply some statistical features. You can use like the minimum, the maximum of the sequence, and so on. So how we can do this? So you find a starter notebook ML machine learning. So here, so I am going through this notebook too. I think I still have time. Okay. So first, let's import our libraries. Okay. Okay. So actually, you need to install the LightGBM library and the TIC-QGM library if you don't have it. Okay, so here first of all, so I am going to load the data, the embedding data of each amino acid. So if you can see this data, so you will have the amino acid, the letters of the amino acid that we have in our sequences, and the embedding of each one. So we have the embedding 0 until 1023. Okay, so the first step is to create a dictionary that contains the dictionary with the keys are the amino acid and the value are the embedding of this amino acid. So we can perform this. So we'll have our embedding feature dictionary. So you can see. So actually, I apply the mean of. So actually, the results here are the minimum, the average of the 100 and the of the 1,000 features. So because it will take so much time to map them. So actually I perform the mean from the beginning to speed up the process later on. So now we're going to load our train and test data. Okay, so here what we are gonna do. So we have train. Okay, so we are going through its sequence, and we map each letter with the corresponding value. Okay, with the corresponding value for the train and for the test. So in this step, we'll actually convert our amino acid to some numerical value, and after, so we can do whatever we want with this value. So we do the mean of the sequence, the max, the STD, the variation, whatever. Take the first, for example, the first value and the last value, and so on. So to perform this, so I just apply. So I just I will call for parallel computing because it will take much time to do it. So we have the number of jobs. So so the number of jobs is the number of CPUs that this function will use. So in your case, so to be safe and to not avoid your laptop to be crashed, or you are running out of a memory, so you can set it to 2 to be safe. So at like maximum, he will use 2 CPU to calculate this. And for the Shanghai, so actually for the Shanghai, since it's our memory, it can't fit all this value, so all this value at once. So we are going to perform this by Shanghai's line. So that means in each step we will take only for example 2,000 rows, and we apply we apply all the feature engineering unit, and we save it for later on. So here, so we can choose, so we can do this by get the data frame chunk. So this function will split our data frame to equal chunks with the length equal to chunk size. And we perform the get feature function, get feature data frame train. So this function example do the actually take the sequence after we map them with the numerical value, and we apply the mean, the maximum, the STD, the mean per axis by the last axis, the maximum by the last axis, and so on. So I think I restart the kernel. Okay. Okay. So I'm going to load them from here. Okay, so here we'll find you will find something like this. So the ID, okay, the target. Oh, this is the test. Okay, so this is for the test. So actually you can see that we mapped our sequence that composed of amino acid to some numerical value that we can use later on to train our model. So this is for the test. This is for the train.
Sorry, Mohammed, I just wanted to interrupt quickly. We're just coming up to 10 a.m. now. I'm happy for you to finish. We're just going to delay the start until you're finished.
Yeah, it's just I need 1 minute. Okay, cool. So actually after creating the train feature, we're going to split them to train and validation, like we did in the deep learning approach. Just to have our train and validation, we're going to define our model. So in this notebook, I am going to use a light GBM model. So I need to define my parameters, so the bugging fraction and so on, the learning rate, the feature fraction. This is 0.4. Okay, the max depth and the metric will be multi-log loss. The objective is multi-class. The number of classes, so the train target point unique, and the seed, and so on. And I need to define my my features list. So actually, this is a small list of features. So, but you can add more to them. This is the function that allow me to train my data. So just I told you, I am using a light GBM model, so we can use another model like XGBoost, CatBoost, so any kind of other model of machine learning model. So actually after the train is done, so I will have the prediction of the text and the validation prediction, just if I would like to check something in my validation and so on. So for the text prediction, I am going to save it in submission in the CSV file to be submitted to the backend. Okay, so so I think I did already this. So I have the file. I'm going to download it. Okay, my connection is not bad. Where I can find Zindi platform. So I think that's so. Just we need after it. So after save the file. So just you need to submit it in the competition, and you'll get your score. So I think I am done here. Okay, so I think I'm done, Paul. So you can. So we can start.
Okay. Great. Thank you so much.
Okay. Welcome.
Okay, so thank you very much to Mohammed for that. I'm just going to end the screen share. Okay, cool. Thank you so much, Mohammed. And Mohammed has also kindly offered to stay on this call for the next hour or for as long as anybody needs. So if you do have any questions, you can feel free to ask them either by the chat or just switch your microphone on and ask, and he'll be available. And then, as I said, around midday, John and Whitaker will also do a live stream, and we'll share the details of that both via the WhatsApp groups as well as on the discussion board. Good. So with that, I just all that remains is for me to share the password. So that is it, and so that's the what is happening here? There we go. So there's your password. So that is the KWPCB. That's the access code for the data, for the encrypted data set. So once you download the data, it's in a zip file, and that is the code to access it. So the competition will open shortly, and all that's left for me to say is a very big thank you to everybody, and very good luck with this really exciting challenge, and may the best data scientist win.